Welcome back to the Groundwater Vistas videos about wells. In the previous video we created a situation with one well, extracting well from the aquifer, and now in the second video about wells we will modify that. In order to do so we need to do some changes, so let's first clear the view. The model will still be there but we won't see the outcome, so go to plot, what to display, and check off particle traces and contours as well. So the only thing which is left is a well and these analytic elements. So I suggest you just to delete the analytic elements, and also I suggest you to delete the well. First, let's be correct. Save it under new name. I forgot that. So save as, and let's go to, in my case I created a folder name 7, and let's call this wells. It will be double wells, so let's call it in plural double wells 2. Save it. Change the root name, yes, we will change it to wells 2, and also wells 2 here. And also we'll go to model, path to models, and change it to folder 7 wells 2. So that should be fine now. Now let's delete this well, and we would go to boundary condition well, delete. You could do a window just like this, and you delete it. So now we will create 2 wells, which would be practically in 1/3 of each on the middle line of the aquifer, but like in the thirds, somewhere here and somewhere here. One will be infiltrating, the other one will be exfiltrating. So, that means pumping well. So the water is flowing from the left to right in natural flow. We will try to revert the area in the middle, the flow. We will try to revert the flow in the middle of the area. So the well on the right side would be infiltrating down, and that one would be exfiltrating, pumping on the left. So let's start with the extraction well. Boundary conditions, insert, digitize, single cell, somewhere like 1/3 of the aquifer. And now we won't say it's 1 liter, we would say it's half a liter. So it's minus 0.3 zeros and a 5. And let's add one more well. Boundary conditions, insert, single cell, and that well would be infiltrating well, so same amount but positive. So the relative exchange of water in the aquifer would still be 1 liter per second, because half liter is being extracted and half liter is being inserted into the well. Might be deceiving that you see one well and you don't see the other. Probably I did not put them on the same line. What to display, finite grid. It's hard to see. We could zoom in. They're not on the same row. That doesn't matter. So plot, what to display. We'll switch off finite difference grid, but we can switch on the velocity vectors and contours at the moment. We still have the calculation. Don't be shocked that we still have the previous calculation there. We have not changed that. Vistas does not remember that, does not know that we changed it and didn't do the calculation. So that's what we are going to do now. So let's go model, mod flow, create data sets. Let's check it. It's still okay. Our folder, folder called folder 7, now in my videos where I play the videos, where I save them, so I have to go all the way again to YouTube. You see wells 2 is being created, bunch of files here. And now let's model it. Model, mod flow, run mod flow. Click on cell by cell flow. So what you see here, that we created a little complicated situation. It's not quite what I expected. It's not quite strong as I expected. We can increase that, but certainly you see if we zoom in the area of this well on the right side, the water is running out from this point, so it's infiltrating and distributing water around the well out. On the other end, if we zoom in this well, it's the case as previous. The water is infiltrating in, and there are few areas like here where the water is flowing both directions, to the left, to the right, so there is not remarkable flow, but it's not exactly what I planned. There's kind of a strange zone. It's a combination of the wells and the actual aquifer working. So what we might try is, let's try, if we go to boundary conditions, wells, and if we double click on the well, let's see if we're successful. Let's increase the amount to 1 liter in both. So 1 liter negative, 1 liter positive, and see what happens. So let's see a model, mod flow, create data sets, model, mod flow, run mod flow. It's a little better now. It's a little stronger. As you see, the general flow as was before, it's from the left to right. But since we created wells and we created the opposite flow in the middle, that's actually flowing from this well directly to this well. So there is an area around here, like this area, where the water flows from one well to the other, opposite direction. So in case there is a contamination, those who take a contamination class may have a look into wells. That's exactly what is there presented. That we actually revert flow in a given area. If there's a contamination, we can catch it up in this well, and we won't let it flow towards right. Let's say there's a city with drinking water, so we can protect the city with this system. If you look through the cross section, you could see the water flows from the left to right in general, but there is an area where the water flows the opposite way. It's in the middle. So that would be the modeling of it. Oh, that's confusing. Sometimes, okay, we have this window too small. So let's increase it. Now let's click on this. I think now it should work. Okay, it's been redrawn. All right, so let's try particles here as well. The environment of Vistas should remember the parameters we have set up in the previous case. So let's now switch off the velocity vectors so we see better, and let's now have a look. Let's do ring around this. One model cannot do both reverse and forward particles, so what we can try, let's try the opposite. So let's see analytical elements, particles, circle. Let's circle about the infiltration well from the middle, and let's put maybe 100 particles in here. Does not really remember the travel time, so let's go again to 100 years. This number and 2 zeros. And let's check model, mod path, particle options. We will go forward now. And here it remembers, so it's a little strange. And in plot, particles options, here it seems it remembers all the previous settings. So let's try that again. Model, mod path, create data sets. Let's have a check. It seems no errors. Model, mod path, run mod path, wells to PTL. Alright, it's kind of nice picture here. Too many numbers, and too many arrows. So let's decrease the numbers. Plot, particles, options. Let's time posting every 10 years. Will be less numbers. The arrows. So you see that it's an exfiltration well, so the water is shooting out. Here it flows towards the river, and here some of the particles end up somewhere in the aquifer. Some particles actually take kind of a bow and revert to the boundary condition to the river, and some actually travel from this well, from this extraction well, to the infiltration well. This one didn't make it in 100 years, but the others were a bit quicker, so they actually ended up there. But it was nearly, you could see it took them 80 years to get to the half, so here another 20 years. So it's actually quite a nice picture. So that was relatively quick. It was the video number 2 from wells, or number 7 in total. And we will continue with the last video about wells in a minute.